How are you, my friends? This is Calculus 1 solved question. In this video, we will find the slope predictor formula, or we can call it slope predictor function, tangent and normal lines. We'll see some examples. You can check always the playlist Calculus 1 lectures for the lectures. Question number 1, given this function f of x square root of 2 minus 3x, let's find the slope predictor formula. To find that, we start with m of x, which is the limit of the difference quotient, f of x plus h minus f of x divided by h. So we can replace now x plus h in the function here. So it will be square root of 2 minus 3 in the bracket, x plus h minus the function itself divided by h. Now, if we try to replace h here in this expression up and down, we will have the problem of 0 over 0. So you try to put here h, 0, and here 0. So we have to do something to find the limit. We rationalize the numerator. We have seen some examples similar to this. So multiply both numerator and denominator by its conjugate. Now the conjugate will be this square root plus this square root, up and down. This is rationalizing the numerator. So let's multiply here the difference between two squares, and here we multiply h times all this bracket in the denominator. So we have to be patient here. To simplify, 2 minus 3x plus h, we multiply that minus this one square root times this square root becomes 2 minus 3x. So this will be 2 minus 3x minus 3h minus 2 plus 3x. You can cancel here things, 2 and minus 2, 3x minus 3x. You are left with the minus 3h. And here we have the h outside with this bracket, so we can cancel the h. So m of x will be minus 3 over all this expression. So we find the limit as h goes to 0. We can replace now by h by 0. So we will get minus 3 divided by 2 square root of 2 minus 3x. So this is actually the derivative, which we'll see that in the coming lectures. Now here we have a nice question. Given the function, the same function in exam question number 1, find the equation of the tangent line to the given curve at x equals minus 2. To find the equation of the tangent line, what do we need? We need the slope. To find the slope, we need the slope predictor function or the slope predictor formula. Okay. So this is the function. X is equal minus 2. You see that in the given, x equals minus 2. So this one will be x1. Now to find y1, it will be f of x1. Just replace minus 2 in the function here. Minus 2 times minus 3. 6 plus 2, 8. Square root of 8 will be 2 square root of 2. So this is the point here of tangency. Minus 2, 2 square root of 2, x1, y1. Now the slope formula we have seen from question number 1. So it was m of x minus 3 divided by 2 square root of 2 minus 3x. I will show it to you quickly. This is the formula here, the L1. This is from question number 1 solution. All right, so from there we can find m, the slope, if we replace x by this value, which is x1. So that will be minus 3 divided by 4 square root of 2. Rationalize, multiply up and down by square root of 2. Minus 3 square root of 2 divided by 8. This is the slope. Now the equation of the tangent line, y formula, you know the formula. Y minus y1 is equal m times x minus x1. Put the numbers there, and then you can simplify. So this one is the equation of the tangent line at x equals minus 2. This is a tricky question, guys. You can take a minute, pause the video, please, and try it yourself. Find the equation of the tangent line. See, I put question number 2 so that you can understand the steps. Find the equation of the tangent line to the graph of the function f of x equals absolute value of x at the origin. So I gave you the point x1, y1. I gave you the function. We need the equation of the tangent line at that point. What do you think? Ready? Let's go. This is the function f of x, absolute value of x, which is v-shape. We know that. Let's try to find the slope predictor function. M is equal to the limit of the difference quotient as h goes to 0. Now, it's not easy to find this absolute value, so we can divide that into limit from the right and limit from the left, two-sided limits. So M from the right, the slope here from the right, it will be the limit of f of 0 plus h minus f of 0 over h as h goes to 0 from the right, from here, see, from the right. So when we simplify that, it will be the limit of absolute value of h divided by h. Remember, this is the derivative here. The limit of absolute value of h divided by h. You can use the formula from algebra here. You know, absolute value of x can be x if x is positive. So now h is positive, so this will be h. H over h will be plus 1. So the slope is plus 1 from the right. See, from here. Now let's do m from the left. The limit of all this difference quotient as h goes to 0 from the left, from here, from this side. So we reach limit of absolute value of h divided by h. Now remember, h is coming to 0 from the negative, so it is negative from the left. So absolute value here, if it is negative, it will be minus x. So this will be minus h over h. It will be minus 1. So the slope is minus 1 from the left, and the slope is plus 1 from the right. Two-sided limits are not equal. So the slope is not defined. So there is no tangent line at 0. So this is a continuous function. This one is nice V-shape, but we cannot draw a tangent line at the origin 0, 0. Later we will see that we can call this sharp corner. This is really nice question. Question number 4. If 10y is equal kx plus d, 10y is equal kx plus d is the equation of the normal line to the quadratic function f of x is equal x squared plus 4x minus 12 at x equals 3. Let's find the value of kd. So what do? Take this function, find the slope. This is x1 here is equal to 3. You can try it yourself, please. And then find y, find the slope of the tangent line, find the slope of the normal line, find the normal line itself. Then you can compare with this given to find k and d, then you multiply them. There are nice steps here. So this is the function, slope predictor formula for the quadratic we have seen many times. M of x is equal to 2ax plus b. 2 from the formula. A is the coefficient here. X now is x1, 3, so I can put 2 times 3 plus 4 here, the coefficient of the x. So the tangent slope will be 10. Now we know the tangent and the normal, they are perpendicular. So if the tangent slope is 10, the normal slope is minus 1 over 10 because the product should be minus 1. I have x1 is equal to 3 given. Let's find y1. So I replace 3 in the function itself. 3 squared plus 4 times 3 minus 12 will be 9. There's 12 here minus 12, that will be 0. So I have the slope of the normal line. I have x1 and y1. I can use the formula here, y minus y1 is equal m, the slope for the normal, m sub n of x minus x1. Put the numbers there, y minus 9 is equal slope here, minus 1 over 10, x minus 3. Simplify the equation until you get 10y is equal minus x plus 93. Now you can compare. Look at the question here. 10y is equal this, kx plus d. So this is k minus 1 and the d 93. Multiply k and d, it will be minus 93. Now, for more questions on tangent and normal lines, you can see Calculus 1 lectures, lecture number 2. And for more questions on Calculus 1 in general, you can see Calculus 1 solved question. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.